Hello folks, Sam Owens here, and I'm doing something that people have commented about the battery disconnect relay. This is it right here, and it's powered up through my portable power station. Red light right there going in. Inside of here is a relay, and there's also a remote control circuit that when the relay, it has to be powered up all the time, the remote does, for the remote to work. So there's always going to be a small drain. Nobody has stated what the drain is. All they say is if you use this to store your vehicle, and it's just sitting there like that, it's going to drain your battery in just a couple of days. Well, I'm going to do the test that people talk about but don't actually do. I don't know why they don't make a video showing what they're talking about. So I've got this totally powered up. Right now, this powered up right through here. I'm measuring current right here. This is clicked on to the positive lead, over through the meter and out the negative lead to the power. So the power is going through the meter, back out, through the relay, and so we're able to measure the current. That is 7.73 milliamps. Milliamps. That is such a small DC power drain. Now, we're going to operate the remote control to show you that this does have power on coming from the power station. And if you listen carefully, let me see if I can get it to where you can hear it. Listen. Made a snap, and look at the power that it uses when it's powered up. 220 milliamps. 220 milliamps. It jumped from 7. That's okay. Your car is running when you activate it, your car is running and it's not draining the battery. Your alternator is keeping everything powered up. So it's not a problem when it's on. It can draw that. But if it were drawing 211 milliamps just sitting there, that would drain your battery down pretty quick. But turning it off, 7 milliamps. I'm going to set it in a location off of my bench. I just wanted to use my bench as a demonstration of the connections, the readings. Okay, this is my test setup. This is a power lead with the power port connector, and that's a power port that's connected to my battery. I do that for emergencies or when I want to get some power out of the car that I don't have to turn the key on. That's it right there. I put this on the 20th of March, the morning, and the battery voltage was 12.4 volts. This is the 22nd of March, and the battery voltage is still 12.4 volts. I haven't moved the car since then, and I haven't cranked it up or turned anything on, but my battery is still connected, so I'm getting normal drain just from the car being connected. But this is still a valid test that people are thinking that this thing is really drawing some current when it is not. No one has shown me what they're talking about with the amount of current that they're dealing with. And that's what pulls your battery down, is the current drain. So we've got 2 days on us. I'm going to come back periodically and we'll check and let you know how far we got to go. Okay, folks, I think the test reveals that very little drain on the battery with this battery disconnect relay, just sitting idle, not energized, and only draining for the remote control circuitry in there, which we saw was 7.70 milliamps. And there is a formula that you can use to determine how long a battery is going to last with a drain like that, or any particular drain that you want to come up with. And the formula is the rating of current in the battery, which most batteries can be an average of 50 amps, and you divide that by amps. Now, amps, if it's not amps and it's milliamps like what we have, then you would divide it by 0.00770. And then that will give you the number of days, because these are ampere hours, that it would take to completely deplete the battery. Now, we're not looking for that. We want the 20% or something like that, so you would need to knock that down. So it gets into a formula thing, but the main thing is, you see, this is not a big drain that is going to run your battery down in a couple of days.